When you did your flip notes, and we talked a little bit about it in class, law of sines, talked about there's a tricky part to it, and I said we'd get to that tricky part on Monday. Well, here we are. We're asked to solve a triangle, and we're given some information. So if we try to draw our triangle, I know that this angle B is 45 degrees. And I know that side B across from it is 27, and I know that side A is 28. We have kind of a problem here. Because I don't know these angles, I don't know if my triangle is shaped like this, or if my triangle is shaped like this. And that drastically changes angle A and angle C depending on what the layout is. Either way, angle B is still 45 degrees. Side A is still 28. And side B is still 27. But my triangle shapes are very, very different. So we have the potential for there to be two different sets of triangle measures. So when we set up our solutions, I'm going to have angle A, angle B, angle C for this triangle, and angle A, angle B, angle C for the second possible triangle. Same thing with the sides. Now they both, B is always going to be 45. A is always going to be 28. And B is always going to be 27. But when I solve for one of these other angles, I need to come up with both of them. Well, how are we going to do that? Let's look. We're going to set up law of sines just like we normally would. 27 over the sine of 45 is equal to, I have 28, we're finding angle A first. 28 over the sine of A. When we solve, divide by 27. The sine of angle A is 28 sine 45. Close it, divide it. So it's about 0.733. And again, we have to remember our unit circle. Because I know sine is positive over here and they're all just reflected across and still positive on this side, I know that whatever angle has a sine of 0.733, there's another angle that's obtuse that has the exact same sine. Remember reference angles. Okay? If I take the sine of 150 degrees, I'm going to get the same answer as if I took the sine of 30. So when we check second sine, second answer, I come up with angle A equal to 47.16 degrees. That's an acute angle. That tells me I'm looking at this version of the picture. So I'm going to put my 47.6 here with this triangle. Well, how do I get this other one? Well, again, think about 30. 30 and 150 are the same. So to get my other angle measurement, I'm going to do 180 minus the 47.16. And I find out that that could also be 132.84. There's my obtuse angle A. 132.84 degrees. And we can check just to be sure. Sine of 132.84. There's my 733. Comes back up the same. This is the hardest part. Once you got that, it's just two little problems where we finish out the rest of it. So we'll go back to our, quote, larger looking triangle to find angle C, 180, minus the 45, minus 47.16, 87.84 degrees. And then we can set up 28 over the sine of 47.16 equals C over the sine of 87.84. C times the sine of 47.16 equals 28 times the sine of 87.84. Divide through. And side C is 28 sine 87.84 divided by the sine of 47.16. So side C is 38.16. And we double check for reasonable. That's the largest angle. This is the greatest side value. Smallest side, smallest angle. So we're at least in the reasonable range. Let's go back to our other triangle. (180) minus 45 minus 132.84 is 2.16 degrees, which is this little tiny acute angle right here. And we'll use the same law of sines process to find our new side C. 28 over the sine of 132.84 is equal to side C over the sine of 2.16. Same relationship, right? I know this sine value is the same, so this proportion is the same as that proportion. C sine 132.84, 28 sine 2.16, divide, and C equals 28 sine 2.16 divided by sine of 132.84. And my side is 1.44 units. It's drastically smaller than the other ones, but the angle is drastically smaller. And again, see, I can't rely too much on proportionality of angle to side, because these angles are drastically different. But 27 and 28, not so much. But still, the largest angle and the longest side, middle, smallest. So both of these sets of triangle information are required when you have a problem like this that does not connect the two sides by an angle.